so you can know you can hear us, that would be great. Let us know whereabouts you are, what country you're from. Then we'll get started very quickly. Just to let you know that at the end of this presentation, you will get a copy of you'll get a certificate, and then within the next 24 hours, you'll get a recording so you can watch it again and share with colleagues, and also a copy of your presentation. Be great if someone could just say something in the chat box, then we'll know that we're live and people can hear us. I can see that there are definitely some people in the waiting room. Oh, great. I can see someone is typing. That's brilliant. Hello. Hi. Hi, Stacey. Thank you so much and welcome from Guyana. Do put your questions in the chat box as we go through this, and Josh will we'll answer them, or we'll pick them up at the end. So thank you for joining us. Thank you, Josh, very much as well for joining us and giving up your time to do this presentation. Josh is a former teacher, 20 years experience teaching maths. He's a trainer, a consultant, and obviously an author, and he has written Grade K, Book 1 and Book 2 of Max Maths, Making Real World Connections. So thank you very much, and over to you, Josh.
Thank you very much, Amanda. First of all, I wanted to say welcome and thank you for giving up your time to come and see us this morning. It's a real honour to be able to meet you all, although it's only virtual. I am really excited to be working with you and to be talking about Max Maths with you today. And I hope you're all well. So I'm going to begin. Hopefully you can all see my screen with a presentation here. So my name is Josh Lury, and I'll do a brief introduction and then we'll get started with our aims for today. So here's me. This is my name. So my academic background is I have an MA in philosophy from Edinburgh University before I trained as a teacher at Cambridge University way back when. And since then, I have been working as a teacher, as an author, as a consultant, speaking in conferences and doing training for schools. I'm based here in the UK. So the schools training that I do is often giving staff meetings or staff development or supporting a school where they've been struggling to implement their maths. That's me, that's my background. I began working in schools for children with severe and profound disabilities, often life-threatening disabilities. I spent most of my career teaching in primary schools, and I have done some teaching in secondary schools as well. So that's my background. These days, most of my work is in authoring and writing textbooks. And obviously, we're in a situation where COVID has shut down a lot of the work with schools. So hopefully that will start up when this whole thing is as back to normal as we can hope to be. Anyway, so I'll say thank you again. Let me just get started with our aims for today. These are the three main aims that I've put into the sessions for today. As Amanda mentioned, I authored the Grade K, the Grade 1 and the Grade 2 books. And so I'll be focusing on the materials in those grades. I believe there are some other sessions with the authors from the later grades, but I think what I picked out should exemplify the philosophy and the features of the series and the approach that it takes. So I'll just briefly talk about that. So the first section, I'll take you through a structure for the design of how the lessons might look and how the material looks. Through that, we'll develop an understanding of what's called a CPA approach, and I'll talk a bit more about that later, but that's quite new in the UK over the last 5 to 10 years, and it has been teachers have been developing some use of it in this country, and I'll pick out some of the nuances around that. Just as an introduction to that, CPA stands for Concrete, Pictorial, Abstract. So that's an approach using well, I've got some here. Hands-on resources, some strong images, as well as some calculation fluency with the abstract calculations and some of the other abstract representations. And I'll be talking about how Max Math approaches that. And finally, I will look at how Max Maths can support teacher development and pupil success, and the ways in which these features could go to support some stronger teaching and learning in schools that use it and use it with some insight into how it's designed. So that's what we're going to be looking at today. I'm going to start with looking at the main features and how the lessons have been designed and how the features fit into the process of teaching, and hopefully will enable teachers and learners to access the maths in a rich and exciting way. So I will begin with that in just a moment. Before I do begin on that, I'd just like to mention that the parts that I've picked out are not completely at random, but they're just features from specific places. And so I've started with some work around understanding number, and this is from grade 2. So to exemplify how it's been designed, I've picked out a chapter from grade 2, early on in grade 2, about understanding numbers to 100. And hopefully through that we can see how it fits, how it works. These are just snapshots from the different parts of it, and you'll see that there are lots of different aspects that go alongside it. Right, I'll begin. So each chapter begins with a start thinking exercise. I'll let you have a look at this. So here we've got a strong visual of a 100 square and some open questions. So I've got an open question here. What patterns can you find in this 100 square? And we've got we've got a slightly more closed question. What numbers are covered? And alongside that, the words, how can you tell? And so these are designed to be just what it says, to start thinking, quite open, to engage all the learners, to engage their mathematical habits, in this case, pattern finding, and to use some questions which enables all of the students to offer their own conjectures, offer their own ideas, to look for patterns, and to engage with the subject ready to learn in that chapter. So there's a start thinking exercise, and the teacher can use that to generate some discussion, to test out some hypotheses, to come up with some potential answers, to agree or disagree, and so on and so on, and to adapt in different ways. It may be that a teacher looks at this and thinks, oh, the class quite enjoyed that. We'll have another go with this, and I'll use 100 square and we'll cover up some different numbers and we'll look for some different patterns. You can see that it's been carefully chosen to generate some understanding of numbers with 7 in ones place. So looking at the patterns in the column of the sevens. It's also been designed to look at patterns for numbers with 7 in the tens place. So although the dots look like they might be placed at random, they're not. They're placed so that we can have a discussion and think about some meaning of the digit 7 in these numbers. And then there's this one outlier over here in the number 99, so that we can start to think about numbers. So 77 here, 99 here. Isn't that interesting that some numbers have 2 digits the same? And if we track that, we can start to see. So it's designed so that some students may see this diagonal line of interesting numbers that have 2 digits which are the same, and we can talk about how the same digit can have a different meaning, which as a math specialist I find interesting and enthuses me, and I'd hope that we could use this resource to generate some of that same enthusiasm in our pupils. So it begins with a start thinking that's meant to be a rich and open discussion. We then move on to the next aspect of lesson design, and the first stage of the lesson is called Let's Learn Together. So here we can see that this is taking the idea of 2-digit numbers. We're learning the place value of them. We've used some strong representations here of physical resources that represent tens and ones alongside. So we've got a visual here, and that also could be a concrete resource. I've got these are base 10 equipment here, and it says these numbers are shown using place value. So each number, find these numbers on the 100 square, referring back to the start activity. How do you know where to look? And you can see again that it's designed with this pattern in mind. So we've got another of these interesting numbers with 2 digits that are the same, and then it moves across this row of the 20s. And the idea would be that in this Let's Learn Together section, the teacher leads with some clear exposition, some guided questions, and opportunities to give the new learning to the class in a rich way, in a visual way, and in a way that helps them develop some clarity about what it is they're going to be learning in the new learning for their lesson. We then move on to the next stage once they've had a good solid grounding in the fundamentals of the lesson, and we move on to the let's try it. And this is the next stage of the teaching as it's designed, where the teacher gives the pupils a little more freedom and takes a bit of a backseat. So we might think of this stage, the let's learn together, as the teacher does. The teacher explains a lot. Here, it's where we're working together as a class, where perhaps we talk about this as a class, we generate some understanding. You can see again that this has been carefully designed so that we've got the digits 3 and 5, and it's been designed so that we can talk about the value of the digit 3. And although it looks like it's just 3 new questions, in fact, there's an opportunity for some quite deep discussion about what does the 3 mean? What does the 5 stand for? This 5 is different from this 5 in the ones and this 5 in the tens. What about this number with 2 3s that are the same? Is that confusing, or is that something we can talk about a bit more? Again, it refers back to the 100 square. So we've got these strong visuals and these strong representations. So at this stage, the teacher would expect the pupils to work with a little more independence, but not full independence yet. This is a class discussion, or certainly could be used as such. Then the lesson moves on to the next section, which is let's practice. And this is where the students would be expected to work independently. And I've given the first part of this question here so that we can see how this builds. Here you can see a real life context. Letitia is counting objects. She's sorting out the toys in her room and has labeled how many there are. And the questioning in this section builds on this. So it begins with a real life context, and the question builds so that in the next stage, it asks the students to represent these numbers on their place value charts. We have tens and ones. Then it asks to say the pupils to say the value of each digit. So they'd be able to say that 87 here has the value, 8 has the value 8 tens, 7 has the value 7 ones, and so on and so on. And then it suggests that the pupils do a similar real life task in their classroom of finding some objects, and it could be stationery or it could be PE equipment, where they find and count them together and label the total number, or it could be the number of students in the class, and they write labels for that and talk about the value of each digit. So you can see that we've gone through a process of opening up the thinking, teacher leading the new learning, and the focus is very clearly on the value of the tens and ones. The teacher giving the students a chance to demonstrate their emerging understanding. And then here we have a real life opportunity for the students to work on this. And the lesson design works so that we have been building that understanding, and the students develop their new learning independently by this stage. So they go through a very clear process of the teacher demonstrates the new learning, the students have an opportunity to explore it, and then the students have a chance to work on it practically, particularly often with real life contexts. Now, I'm going to move on to explain some of the others. They then have further opportunities. So that all of that was in the student textbook, which is a very colourful resource with lots of interesting resource. They then have their own workbook. So I've got an example here. I'll hold up to the screen so you can see, which is a write-in workbook where the students can do further independent practice. So here I've taken out some of the examples of their learning that they would be working on independently. So they can write in this book. This builds on the start thinking exercise, as you can see. And then question 2, they're looking for different numbers, and you can see that it builds on their understanding of the tens and ones. So all of the way through, their work is very strongly related to visuals and develops as they go through the fluency in their student book and in the workbook. So that all the way through, there's this coherent set and this process of learning so that they can build their understanding as a class and independently. In the Pupil Workbook, there is then, at the end of each chapter, a chance to do some self-assessment. So here's one example of self-assessment. This is a task where the students have to draw on their knowledge of tens and ones and demonstrate to themselves and to the teacher that they've genuinely understood how this works. So 38 would join to 3 tens and 8 ones, 68 would join to 6 10s and 8 1s, which is down here. I haven't been able to fit the whole thing on the page. There's then also opportunity for the students to engage in a learning journal. So in the workbook, at the end of each chapter, there's this learning journal where there's a opportunity to talk about their learning, there's opportunity to show what they've learned, and then also this opportunity to talk about mistakes that they may have made or that the class may have made, and to celebrate some of those mistakes as learning opportunities rather than as something that they've just got wrong. And then there's this happy face, emoji version of self-assessment for the children to be able to think about their own learning. So that's a quick fire run through the spine of what a lesson would look like. Hopefully you can see that it's designed to be engaging, colourful, have a real life context, but also have a very clear mathematical focus at each stage. So the students can together and independently build their confidence to work through the concepts as they go. I'm going to move on. There are dotted through some other features which, although they are not perhaps part of that spine, I think they're very valuable. So I'll just share some examples of those from different stages. Here you see some maths challenge activities. So through the workbook, in every chapter, you'll find a maths challenge, or you might find more than one. And the maths challenge will be, perhaps in this case, it's a chance to practice some estimation and a discussion activity. And you can see that it takes their learning that they've done about place value, and it sends them off in a slightly different direction to deepen their understanding and to challenge their understanding, but also give them opportunities to think for themselves. So although the teaching itself is very structured and gives them the core fundamentals they need to be able to understand the maths, these maths challenges give them an opportunity to go off and think independently, and to think perhaps 90 degrees from where they were coming from before, and to think, can I apply and adapt my learning in a flexible way? And here's another maths challenge here, where the avatars represent the children playing a mystery number game. And so this is an opportunity for the students to engage in this game. So this avatar is saying, my mystery number has 5 10s and 8 1s. My mystery number has 6 10s and 2 1s. And then the challenge is to try and work out numbers that are between the two mystery numbers. They might want to work out the mystery numbers, and then some discussion around the number of different solutions it could be, justifying which numbers it could be, and working on that. So there we have, these math challenges are dotted all the way through as a way to cater for all of the students to engage in that deeper thinking in the concept, as well as having the very structured approach. I'll mention the avatars. These are all the way through the books, and you'll find the avatars popping up with these speech bubbles. This is from a later unit here, where these are very much pupil facing and are supposed to guide the students to being able to have some of those mathematical thought processes for themselves, and to embed those habits of mathematical thinking. So in this case, this avatar is demonstrating that if he knows 2 plus 3 is 5, he knows 2 10s plus 3 10s is 5 10s. And so these are designed for the students to be able to access the learning and feel that they're not having the maths, they're part of learning the maths together, and they can generate this thinking for themselves rather than have to rely all of the time on being told. And so it's another avenue into engaging the students in their own thinking. You may have noticed, and I'll just flick back to these maths challenges, there are these small icons here, and these small icons are also used through the book to illustrate places where there are opportunities to engage in mathematical processes. So the icons, and these are the same through all of the grades, these are the main icons that we use. So this is an opportunity to really involve yourself in some problem solving. So the cogs are for some reasoning, some communicating, so a chance to develop the mathematical language and the reasoning skills alongside that, justifying your conjectures, coming up with hypotheses, testing out someone else's ideas, and being able to engage in expressing your own mathematics. The jigsaw pieces represent connecting areas of mathematics. At this stage, I'd just like to mention an experience of my own when I was learning maths. I think when I was 6 years old, I have a very clear memory of, we were learning from textbooks. And in fact, I'm looking on my bookshelf. I've got an example. I've got the very textbook we learned from. I can remember one day when I was 6 years old, turning the page to work on my next page of the maths textbook, and then turning back to the page I'd done the day before and flicking back between the two pages. And I realized, as a bit of a light bulb moment for myself, that the page on, let's call it page 10, was very much linked with the learning on page 9. And if I was able to learn the learning on page 9, I could build on that and learn the learning on page 10. And I think that stuck with me all the way through my mathematical career. And I learned a strong lesson that day that all of the areas of maths are connected with each other. And if I know one bit of maths over here, I can use that very much to generate my new learning that I need, or my new problem solving skills to learn in a slightly different area. And so anywhere you see these jigsaw puzzles, it's an opportunity to connect different areas of maths together and for the students to have that same kind of epiphany, hopefully. And then representing, so the pencil there, where students might be asked to draw a diagram, or to annotate a diagram, or to in some way model or show how the maths work that they've generated themselves. So we have a textbook with very clear exposition and structure, but we also have these opportunities built in all the way through in every chapter for students to engage independently and together as a class unit in these key processes. One more feature that I wanted to mention before we move on, and that I touched on briefly there, is maths language. So there, all the way through in each chapter, there's an opportunity to really focus in on the maths language. So I've picked one out from that chapter on numbers to 100. Yeah, just an opportunity for students to focus in on the language and to practice the language. And as a final feature, each chapter begins a page spread of a real world context, engage them in the thinking. And I've taken this from the title slide. Actually, this is not from the numbers to 100. You can probably guess by look at this that this is from a fractions unit later on. And there's all the books are full of these lovely double page spreads of with a diagram like this, with children engaging in a context, and then there are some questions that go alongside it. There's some notes in the teacher guide for how the teacher can use this to generate some real world connection, some discussions around this, and to prepare the class with some of the language they need and some of the concepts they need in order to be able to access the learning. And here you might be able to talk about how the fruit is being cut up, how the pizza has been sliced into different parts. We've got some cakes over here that are not yet organized into groups, but perhaps could be organized and shared out. So I think here we have 8, and the students might think, well, there are 4 pupils. How can they share out the 8 cupcakes? And all of the questions that are in the teacher guide or in the textbook itself are there to guide the student's eyes and guide the class's discussion to be able to engage in some of the contexts. We think that's a lovely way to begin each chapter, so that they're already oriented into the learning and already feel like they have engaged with some of the content and some of the concepts they need to be able to learn. So at that stage, that's just a brief introduction to the main spine of each lesson, and then also the features that are dropped in different places that hopefully will engage the students. I should have said at the start, please do drop in any questions that you'd like to into the chat box, and I am happy to answer any of those now or at the end. I'm going to move on to the next section, which is really focusing on how Maths makes real world connections. And it will prepare us for thinking a little bit more about this, what we're going to call the CPA approach, this concrete, pictorial, abstract approach. But to begin with, I'm just going to look at one of the units to do with multiplication. And the multiplication unit, you'll see all the way through the learning, draws in different aspects of real world connection. And hopefully you'll see real objects, concrete objects from the real world. You'll see strong visual representations of drawings and opportunities for the children to do their own drawings, their own representations based on some of the real world connections that we've been speaking about. And then you'll also see that they can then link those real world connections with the abstract maths that they'll be learning in each section. So I'll move on. This is from grade 2 again, and this is the multiplication. This is the chapter that introduces some of the key concepts of multiplication. Although I will say that in the previous 2 grades, some of these concepts have been introduced in a way that lays the foundations for them to be able to engage with the language here. Anyway, so here we go. Here's the let's learn together. So this is this first teacher exposition. And you'll see that there's a very clear opportunity to do some discussion in each class around equal groups and the number in each group. So here there are 3 equal groups, as in 3 bunches of keys, and there are 2 in each group. There are 3 equal groups, 3 towers of cubes, and there are 3 in each group. And then here you can see that we're preparing the class. Well, there are 3 equal groups, and there are 1, 2, 3, 4, 5 in each group. And this is the teacher generating some of the understanding of the language based on those real world connections. I know when I put a decision about how I would teach with this would perhaps be that I would look at the textbook and use the textbook example to generate some of the understanding and some of the language I wanted the class to be able to talk about. And then I would use my classroom environment to make groups, equal groups with the pupils or equal groups with the objects. Again, perhaps the PE equipment or the stationery or any of the painting materials or something, and make some equal groups. And you can see here that again, we have 2 equal groups of 2, 4 groups of 2, 6 groups of 2. And hopefully you can see that they've been carefully designed so that in each of these sections, there are 3 equal groups and the size of each group changes. And in this case, the size of each group is 2, but the number of groups changes. So there's opportunity for the teacher to really focus in on, do they understand how many equal groups, and do they understand how many are in each group, the number of groups and the size of each group. So although it looks like a very simple activity, actually there's been very careful thought about how to generate the real understanding through these real concepts, through these real world connections. Then we move to let's try it. And here you can see that this is engaging the students in some challenges around this learning that they've been thinking about. Make or draw 3 equal groups of 2, 4 equal groups of 2, 5 equal groups of 2, and 2 equal groups of 5. And again, so engaging students in some practical, in some real life activity where they use their drawing skills or use their making skills to make equal groups. And you can see again that these have been designed so that it zeroes in on here. We have a different number of equal groups and the size of each group stays the same. Whereas here, we've flipped over this previous one. So as well as there being just can they make these equal groups, there's also this opportunity to discuss, or did you notice that you could make 3 equal groups of 2 and then 4 equal groups of 2 was easy. So one student will say, oh, I just drew an extra group of 2. And as a class, you can then discuss that. Oh, and then 5 equal groups of 2, I can just draw another group of 2. And you can see that this avatar here is just giving a slight nudge in that direction, ready for the students to be able to make some of those connections for themselves. And then this is from the next chapter. Let's learn together. So this is taking it to the next stage, building on that previous learning, which was all about the size of each group and the number of groups. This, where I said before, we've built some of this counting skills in grade 1. Can we count in 2s? Can we count in 5s? Can we count in 2s? Can we count in 10s? So there's counting in 2s, 5s, and 10s, building the skills. First, we've learned to recognize the equal groups, and now we count for the equal groups. This one goes 2, 4, 6. We can count an equal, and now we know how to do that. And you can see that it's built around repeated addition here, 5, 10, 15, 20, and so on and so on. And so you can see that the concept is structured very carefully so that the students build their understanding gradually and their confidence gradually, so that as they move through the unit, they can make all the links they need. So although the steps are very small each stage, it gives opportunity for rich discussion and to make those connections with the real world objects. And I'll move on. Here's one of those math challenges. And drawing this idea of using calculators here, use a calculator to count the number of legs. And it demonstrates here how to do that. And you might be able to do that as a whole class math challenge. And my suggestion would be that the teacher here has got a really good opportunity to play a game with the class of, let's guess what the calculator is going to say. 4 red, 4 red, 4. Before I press the equals button, let's guess what the calculator is going to say. And we can have some students might guess that it's going to say 8 or 6 or 20 or a million. And you can have all of those discussions and think about, well, let's try and work out what it's going to say. There's a maths challenge again. So here we're drawing technology and these real life contexts together to generate some understanding before moving into the next stage, where we teach how this repeated addition is related to this times button on a calculator. And this is the first time they would have seen that multiplication symbol. And so here you can see that the learning has very carefully been structured so that if they've gone through those previous two sections, here they've got the opportunity to start to conjecture and start to build that understanding of what 4 times 3 might mean and how it's related to these 3 add 3 add 3 add 3, and also how it's related to the context here, or the socks. How is this number 7 related to these socks at all? And you can see that in this case, because of all of that foundational work around the number of groups and the size of each group, students should be alive to noticing that if they describe this as 7 groups of 2, they can see that this 7 multiplication symbol 2 is related to that, and it's also related to this idea of adding 2 at 7 times. And so the learning is built in a structured way, and in a way that gives them opportunities to have these deep discussions. And then as we go through, we build that understanding. There's an opportunity to use calculators, but there's also an opportunity to use these counting skills, and there's an opportunity to use these drawing skills. So in this case, there's a really strong set of images here in this Let's Learn Together section, where students learn how to use their counting in fives to solve multiplications. And it could be through drawing the diagrams, it could be through counting in fives, and it could be drawing on how to use this multiplication symbol effectively. I've chosen all of that from grade 2 because that felt like an opportunity to, because there may be some of you who are working in later grades, but I will say is also, I've got this example from the grade K, and this process builds from day 1 in grade K. So I've taken this very early on, and you can see that this real world context, and we've got this structure of this. First there were 3 balloons, then some burst, now there is 1 balloon. And this practice, first there were 4 cubes, then someone came along and nudged one off, now there are 3 cubes. And this is all in the context of learning for the first time how subtraction works. And it's built very carefully around this storytelling structure of, first there was this, then this happened, now there was this. And in grade K and in grade 1, it builds on this structure to be able to generate understanding of, in this case, you'd have a 3, the numeral 3 to represent what was there at the start. Then you'd have subtract 2, because in this takeaway context. And then you'd have equals 1, and that's what's remaining at the end. And all the way through, there's this opportunity to link their understanding of numerals with the real life context and with strong visuals. And here, it's very much a storytelling approach to understanding the mathematical concept and to introducing the maths. So it begins in grade K, building all of those foundations that they need. And by the time they get to grade 2, hopefully you can see that there's this really strong approach that the students will be ready to build their learning in small steps, but in a very deep way, in a way that they can engage with in a visual way, in a contextual way, and in a way that means their understanding of the numerals is linked back to the representations, it's linked back to the context, and also the technology that they're going to be using to help support their understanding as we go through. So I'm just going to take a slight breath at that stage and give you a chance to absorb some of what we've been talking about. If at this stage you have any questions, please do drop them into the chat. Our next section is going to be where I talk a bit more about the CPA approach and what that means in terms of max maths and what that might mean for teachers who are using this resource. Yeah, so I'm gonna leave perhaps a 30 to 45-second pause for people to type in any questions or to have any thoughts about that. Oh, thank you, John. Just a message saying, good morning from Nevis. Uh, Lovely to hear from you, John. Um, Clear so far on what's been shared. Thank you. Right, I will. I can see that someone is typing there, so I'll just let them finish typing and then I'll move on to the next section. Thank you, Stacey. We've got a question there that we'll tackle with Amanda at the end of the session, if that's okay with you. But thanks for dropping that into there. We'll have a thought about that, and Amanda will just monitor the chat as we go. Thank you very much. Right, the CPA approach. So I'll just mention this again, that the C stands for concrete, the P stands for pictorial, and the A stands for abstract. And this is an approach that's used in different countries around the world and in different classrooms to varying degrees and interpreted slightly differently. I will talk a bit about my own interpretation of what it means for Max Maths as we go through this next section. I will say that there is, so I've got an example here in my study of a maths resource. So this is an example of a concrete bit of maths resource that is a 100 flat or 100 grid, base 10, that I use with students to understand place value in later grades. So this is sometimes what's understood by the concrete aspect. So sometimes a maths resource. So it could be a very specific hands-on maths manipulative, but it also could mean something concrete from the real world. The pictorial aspect is it's very much a representation of a mathematical object or mathematical sense, and the abstract could still be a diagram, but where some of the number understanding or the understanding is abstracted from it. Well, you'll see as we go through the next stage. So I've taken this from, and you can see this builds slightly on what that avatar said to us earlier. So this is from later in grade 2, when the students have developed some understanding of their numbers to 100. So here's the start thinking activity. This is just for them to be able to connect their learning. So you can see this icon here with the jigsaw puzzle pieces. And here it's just a statement here. If you can add ones, you can add tens, and the chart. And here we've got a pictorial representation of these base 10 pieces of equipment. So we're using. So it could be that we then ask the students if they have maybe strips of paper like this, or cubes, or base 10 equipment. Then we would build this into their understanding as we go through. So this is concrete and pictorial at the same time, and here is the abstract version. There's some of that. You can then see that here's another feature. So here's a game time feature where it suggests a game time feature for being able to build this skill. So here's something you might be able to do to develop that fluency. Here's a physical game, but actually you'll see although this is a physical game, this involves some abstract thinking. 20 plus 30 is 50. I scored 50 points. So building on that understanding here, it moves through so that they can use that abstract thinking and apply that fluently. We then move through so that here is a pictorial and concrete representation of how to add 10 to a number alongside the abstract. So here's 43 plus 10 represented in a concrete and pictorial way and represented in an abstract way. And the discussion is, how do these parts link together? And then as we go through, you can see that this concept builds. If we can add 1 10, we can add 2 10s to a number. So again, here we've got the concrete and the pictorial representation of that linked to the abstract using the numbers and the place value so that the students can develop their calculation skills with 32 plus 20 equals 52, all building on that concept of being able to add on 1 10 or 2 10s and that concrete understanding of the place value through to some abstract calculation and opportunities to apply that skill in some more traditional kind of just doing calculations or doing sums. And here we are. Here's the opportunities for them to do that with a maths challenge. So one student, the idea would be here that you've noticed that 54 plus 30 and 34 plus 50 have the same total. Is there a way that they can talk about that and then justify their thinking about why they have the same total? And there's an opportunity for them to be able to talk about how adding the 10s is 5 10s and 3 10s in each case, and that the number in the ones is going to stay the same. And so there's opportunities for them to have that discussion. So the CPA approach, which is exemplified here, is on the page, pictorial representations of the number concepts, opportunities to practice those in a real life way and in a fun way. And then here we've got really how the concrete and the pictorial support the abstract thinking so that as the students go through, they develop that understanding, ready to be able to apply that in an abstract way and be able to be very fluent and sharp in their calculations, and then be able to justify some of their thinking around their calculations. So that's just a quick run through, and I think you'll find that in each of the sections, in each of the chapters in Max Maths, this CPA approach is all the way through. If I was teaching, I would hope that I would be able to use or make some resources with the class that I could use for them to physically enact some of this maths. We could have some of these games, we could play some of these games, and then I could ask them, for example, to make the number 43 from their equipment, and then to put another 10 in that number, and then to be able to justify why some of the calculations are what they are. The idea is not that then they must use those concrete resources or those pictures to be able to solve these questions. The idea is that they could use those concrete to support their understanding, ready to be able to be more fluent in these calculations. And if the teacher says, oh, you've just got this 20 plus 47 wrong, let's have a look at that one again. Let's see what we can do with that one. And then they may go to the concrete resources to check their understanding or to check their answer with that one. This leads in to an idea that students will then have a chance to progress through the concept. So this next sequence I've taken from the Write-in Workbook. So this is the book that looks like this. And as they go through, you will see that students have the opportunity to build these skills in a way that is visual. So here we keep adding 10 more. So we begin with that first adding 10. And here we've got opportunities to use the number line and counting in tens to build some of this understanding. They have opportunities to draw representations of these tens and ones equipment. They have opportunities further down the line to practice that in an abstract way. So here we've got a set of exercises, and I've often built in exercises like this where, as well as having lots of opportunities for practicing the calculations, there's also an opportunity to notice patterns down the columns. So in this sequence here, there's a 45 plus 20 plus 30 plus 50. There's a pattern there, and they may be able to notice some of the pattern and just explain some of the pattern. and then this slight twist to the pattern as the last question here. And we may be able to have, again, you can see it's drawing on that challenge they had before to be able to explain why two calculations may produce the same answer. And in this case, you can see that we've got the same twist in each column, and they're drawing on patterns. And in fact, then they also you may be able to have a discussion about, well, there's a pattern across the row, a pattern across the row, pattern across the row, and so on and so on. As we move further through the concept, you'll see that we've got this same strong visual, but we're drawing back so that now that they can have a new concept, this time adding ones, can they adapt the visual, adapt their concrete understanding to be able to draw on that and be able to develop the new concept of adding on ones to a two-digit number. And again, we build the opportunities in to be able to draw the tens and ones materials that they might need to be able to support their understanding before building some more quick-fire fluency with just the abstract calculations. So each stage, there are opportunities to begin with some concrete and some pictorial methods before they show they're more fluent and be able to do some of the calculations, which are more about pure abstract calculations, building to that efficiency. And then there's a spiral approach to it. So as we move through grade 2, in this example, in the concepts of adding on tens and ones, we use this same visual structure to which we've built up gradually and built up their understanding of tens and ones, so that here we have this tricky area of where we may need to exchange or bridge across a tens barrier. So here we've got 38 plus 4, and we add the tens, add the ones, and notice that we end up with a 42. And this is very carefully built into the sequence so that students build confidence and fluency in this area that actually I know certainly here in the UK causes a lot of difficulties for students around that grade 1 and grade 2 area. This idea of adding where they have to bridge across a 10, and you can see here that the pictorial gives them opportunities to develop real understanding about how that works. So here 56 plus 8 will be 50, add on the 14, and they'll be able to see how that relates later on in to be able to use more formal common methods and how we might carry the 1 or exchange the 1 into the tens column. So here we're using the pictorial and the concrete to really generate the foundations for that understanding, so that as we move through, we can then build. And here you can see that's the final stage from later on in the spiral approach, where having spent a lot of time building this secure foundation, now we're able to solve these calculations by thinking, adding the tens, adding the ones, and understanding that if I've got more than 10 ones, that's going to affect my answer. So I've picked that out from the grade 2 over the course of the year, and you can see how it begins with some of the fundamentals presented in a way that generates some deep understanding, so that as they move through that spiral, as their understanding builds and their confidence builds, they become fluent and they become really able to use their skills to take on these more tricky challenges. So that's just an example of how the CPA approach is used, as well as used within one chapter, is used in a consistent way in the spiral approach so that students build their understanding over time. I'm just going to finish with a brief snapshot of, I've picked out some of my favorite parts from later on in the books, where you can see how all the way through there's opportunities for really rich learning opportunities, investigative work, and a chance to engage with the maths in the way that develops a love for the subject and a sense of mathematical self-esteem in the students, so that they have opportunities to develop their own learning. So here's another feature that you'll see. So you see this icon here, this problem solving icon. So here's a chance to investigate, to do some estimation and to improve. So this is a heads together activity. So it suggests working with a partner, and it's got this diagram that suggests a way of making one piece of paper stretch a long way. And so it says, can you make one longer than 2 meters? So this is taken from a chapter about measurement, and it's a fun example of how you can make a practical activity really deepen their understanding and their motivation around learning measure. I've got another one from a fraction. So here's another one involving a piece of paper. This is a chance for them to engage in this idea of conjecture, to generate some surprise and some deeper learning. So fold a piece of paper in two, then again, then again. What will you see when you open it? It's an open question. I found when using this with even with older students that 50% of the class will guess that you're going to see 6, because they'll go two pieces, they'll know that, 4 pieces, they sort of know that, and so this must be 6. And then you get that element of surprise and then going, huh. And we use this to generate some understanding of not only how to double, not only fractions of halves, quarters, and eighths, but also how you can multiply and how you can divide with numbers in 2, 4, and 8. So you can see there's opportunities for using practical activities to generate some good class discussions. We've got some opportunities to use pattern, harness intuition, and develop fluency. So this is taken from grade 1 to understand number bonds to 20. So if you learn your number bonds up to 10, how you can generate then your understanding for numbers that sum to 20. So this is in the grade 1 material and gives you a chance to really develop some of that thinking. And so to learn that if you know a few of these basic facts, you can then apply that flexibly and understand some other facts. And it uses these strong visuals. So these visuals here, these are 10 frames, and these are used throughout introducing GK and through grade 1, so that students develop a real fluency with that. What have we got next? Opportunities to develop independence, efficiency, and confidence. So here's a heads together activity, and here's the avatar saying, I've learned different methods to add and subtract. And this is where the children have a chance to explore different methods to make decisions about when one method might be better than another method. So they would have learned that 72 add 1 is something that can be solved simply as a counting fact, as the next number in the counting sequence. They will have learned that this is a doubles fact. They would have learned that this is probably a mental fact where the 10s increases by 1 and the 1s increases by 1s, but you might well begin with the 54 and add on the 11. And then later on, they may have learned that this is the sort of question where they perhaps will write out, add on the 1s, add the 10s, and then combine them again at the end. So this is an opportunity for them to develop some independence and also some efficiency for themselves. We've got some puzzles. So this start thinking here has got a misconception, a deliberate misconception, where it looks here like that this quarter is bigger than this half. And this is in the comparing fractions section. And it's an opportunity for students to challenge the thinking that's presented and to be able to deepen their understanding of what a fraction as a part of a whole means. So as well as being presented with everything with methods that are sound and with representations that are strong, they're also presented with misconceptions to challenge and to develop their critiquing skills. All the way through, particularly in grade K and grade 1 and grade 2, I've put in opportunities to link this with physical development and memory development. So here's an example of how to make this as a dance routine or an exercise routine. And this is from the position and direction unit in one of the earlier grades. And this is a chance for the class to work together on using that in the context of dance or exercise and to be able to link that with their physical development. And then also plenty of opportunities to develop practical skills and to apply those practical skills in interesting ways. And the practical skills here are shown in a secure way and then and in a way that they can all follow, and then challenged to be able to generate these mathematical patterns and to take an interest in the patterns they see and to have a fun time counting the rectangles and challenge themselves to draw smaller and smaller rectangles and to be as accurate as they can. Now, I've hopefully left a few minutes at the end for time to have questions or to go through any of those bits or for me to repeat any of those bits. So I will just put this last page there with some contact details that you may wish to take down. Amanda's already mentioned there's going to be a recording sent out. I'll hand you back to Amanda at that stage. Thank you very much, everybody, for listening, and I'm happy to spend 5 minutes answering any questions or anything like that.
Thank you, Josh, very much indeed. That was great, really interesting and insightful walk through the concepts behind and the scientific approach to max maths. It's really interesting. I mean, if we have got some time for a few questions, I just pick up on the one question. We don't plan to replace bright sparks. Max maths, making real world connections, is a different approach to learning mathematics. And if you're in an OECS country, then max maths, making real world connections, has been written to the new OECS standards. So that would be a reason maybe to have a look at that. You will get a copy of the presentation, you'll get a link to watch again, you'll get a certificate along with this, and also in the email that follows this up there will be links to have a sort of sneak peek, to have a look at some of the first early chapters from Max Maths, Making Real World Connections. So do look out for that in your inbox. Yeah, it's good when it is good, isn't it? When you're reminded of things that you maybe have forgotten, and look at new ways of learning things. Thank you, Josh, very much indeed for your time today. If there are any more questions, otherwise we will shut this session down.
I can just see someone's typing at the moment. I'd just like to say thank you again to everybody. It's a real honour to be able to work with you all and to be part of a global conversation like this. So I'm really grateful to have the opportunity. Thank you.
It's great, isn't it? When we can't get out to any of the countries, this is the second best thing. So it's really good. Thank you all very much indeed for giving up your time today to join us, and look forward to seeing you again soon. Thank you, Josh, very much. Bye-bye. Bye, everyone.